You know that feeling when you're waiting for a web page to load and it feels like an eternity? Or when you're gaming online and there's that annoying split-second delay between clicking and something actually happening? That delay you're experiencing has a name: network latency. And understanding it might actually change how you think about the internet. So, what exactly is network latency? In the simplest terms, latency is the time it takes for data to travel from one point to another across a network. Picture this. You send a message to your friend across the room. The time between when you finish saying it and when they hear it, that's basically latency, but for networks. When we talk about latency in networking, we're measuring time, usually milliseconds to be exact. When you type in a website address and hit enter, your request doesn't teleport to the server. It has to travel through cables, routers, switches, and sometimes even satellites. All of that takes time. Latency is that time. But here's where it gets interesting. Latency isn't just one thing. It's actually made up of several different types of delays that happen as your data moves through the network. Understanding these different components helps us figure out why some connections feel slow and others feel instant. The first component is called propagation delay. This is the time it takes for a signal to physically travel from one point to another. Think about it like this. If you're talking to someone standing 10 feet away versus someone 100 feet away, the sound takes longer to reach the person further away. Same principle. When your data needs to travel from New York to Sydney, it's going to take longer than if it's traveling from New York to Boston. That's propagation delay, and it's limited by the speed of light. Yeah, physics actually matters here. The second component is transmission delay. This is the time it takes to push all the bits of a packet onto the network link. Imagine you're filling up a water bottle. The time it takes to pour all the water in, that's transmission delay. If you have a faster connection, like gigabit Ethernet, you can push more data onto the network faster. With a slower connection, it takes longer to get all that data out there. Then we have processing delay. Every router, switch, or device your data passes through needs to look at it and decide where to send it next. That examination takes time. It's usually pretty quick, but it still counts. Think of it like going through airport security. Someone needs to check your boarding pass and ID before you can move on. Same idea with your data packets. The last component is queuing delay, and this one can vary a lot. When your data arrives at a router, it might have to wait in line behind other data packets that got there first. If the network is busy, that queue gets longer and your data waits longer. If the network is quiet, your data might not wait at all. This is why your internet might feel slower during peak hours when everyone's streaming shows or playing games. So total latency is the sum of all these delays. Propagation delay plus transmission delay plus processing delay plus queuing delay. All of these add up to create the overall delay you experience. Now, you might be wondering, what's considered good latency? Well, it depends on what you're doing. For regular web browsing, anything under 100 milliseconds feels pretty smooth. For online gaming, you really want to be under 50 milliseconds or you might notice lag. For video calls, around 150 milliseconds is the upper limit before conversations start feeling awkward with that weird delay. And for high-frequency trading or other super time-sensitive applications, even a few milliseconds can matter. Here's something that confuses people. Latency and bandwidth are not the same thing. Bandwidth is how much data you can send at once. Think of it as the width of a pipe. Latency is how long it takes for that data to get where it's going. Think of it as the length of the pipe. You could have a massive pipe that's really long, meaning high bandwidth but high latency. Or you could have a narrow pipe that's really short, meaning low bandwidth but low latency. Let me give you a real example. Satellite internet often has really high bandwidth. You can download a lot of data, but it has terrible latency, sometimes 600 milliseconds or more, because your data literally has to go to space and back. Meanwhile, a direct fiber connection might not have quite as much bandwidth, but the latency could be under 10 milliseconds because the physical distance is much shorter. Network latency matters more than you might think. When you're video chatting with someone, high latency makes conversations feel unnatural because there's a delay between when someone speaks and when you hear them. In online gaming, high latency means your character responds slower to your commands, which can be the difference between winning and losing. Even in something as simple as loading a website, latency affects how quickly the page starts appearing on your screen. So what actually causes high latency? Distance is the big one. The further your data needs to travel, the longer it takes. This is why content delivery networks exist. They place servers closer to users so data doesn't have to travel as far. Network congestion is another major factor. When too much data is trying to use the same network path, everything slows down and queuing delays increase. The type of connection matters too. Wired connections typically have lower latency than wireless ones. Within wireless, 5G has lower latency than 4G, which has lower latency than 3G, and the route your data takes matters. If your data has to hop through 15 different routers to get to its destination instead of 5, that's extra processing delay at each hop. Sometimes the issue is with the server you're connecting to. If a server is overloaded with requests, it takes longer to process yours, increasing processing delay. And sometimes, old or poorly configured network equipment causes unnecessary delays. A router that's working too hard or software that's not optimized can add latency that shouldn't be there. There are ways to measure latency yourself. The simplest tool is called ping. You can open a command prompt or terminal on your computer, type ping, followed by a website address, and it'll show you how long it takes for data to make a round trip to that server and back. That round trip time is your latency. For example, if you ping google.com and it says 20 milliseconds, that means it took 20 milliseconds for your data to go to Google's server and back. Another tool is called traceroute. This shows you every hop your data takes to reach a destination and how long each hop takes. It's useful for figuring out where delays are happening. Maybe the first 5 hops are fast, but then hop 6 takes forever. That tells you where the problem is. Can you reduce latency? Sometimes. If you're using Wi-Fi, switching to a wired Ethernet connection almost always reduces latency. Closing other applications that are using your network can help reduce congestion. Choosing servers that are physically closer to you makes a difference. Some gaming routers have features specifically designed to prioritize gaming traffic and reduce latency. But some latency is just physics. If you're in California and you're connecting to a server in Japan, there's a minimum amount of time that data needs to travel that distance. No amount of optimization can make your data travel faster than the speed of light through fiber optic cables. Here's something interesting about how latency affects different architectures. In a monolithic application, where all the code runs in one place, latency is mainly about the network delay between you and that server, plus whatever computation the server needs to do. But in a distributed system, where different parts of the application run on different servers, there's additional latency. Each time one part of the application needs to talk to another part, that's another network call, which means more latency. This is one of the trade-offs of distributed architectures. You gain flexibility and scalability, but you can add latency if you're not careful. Companies that run large-scale web applications spend a lot of time thinking about latency. When Facebook or Instagram loads, dozens of different services might be involved in generating that page. Each service call adds latency. This is why big tech companies use techniques like caching, where they store frequently accessed data closer to users so it doesn't need to be fetched from the original server every time. They also use content delivery networks that distribute copies of data to servers around the world, so users can grab it from somewhere nearby instead of halfway across the planet. Another technique is called edge computing, where computation happens closer to the user instead of in a distant data center. This reduces the distance data needs to travel, which reduces propagation delay. Some companies even use predictive loading, where they start fetching data they think you'll need before you actually ask for it, essentially hiding latency by doing work ahead of time. The future of latency is actually pretty exciting. New technologies like 5G and eventually 6G are designed to have ultra-low latency. We're talking under 10 milliseconds or even under 1 millisecond for some applications. This opens up possibilities for things that weren't practical before, like remote surgery where a doctor controls robotic arms from across the world, or truly responsive augmented reality where digital objects react instantly to your movements. But no matter how good the technology gets, latency will always exist. It's a fundamental part of how networks work. The goal isn't to eliminate it completely. That's impossible, but to minimize it enough that it doesn't matter for whatever you're doing. Understanding network latency helps you make better decisions. When you're choosing an internet provider, latency matters just as much as speed. When you're setting up a home network, knowing that wired connections have lower latency than wireless might influence how you connect your gaming console. When you're troubleshooting why a video call is laggy, understanding the components of latency helps you figure out where the problem is. So that's network latency. It's the time delay in data transmission across a network, made up of propagation delay, transmission delay, processing delay, and queuing delay. It's affected by distance, network congestion, connection type, and the path your data takes. It's different from bandwidth, it's measured in milliseconds, and it matters for everything from web browsing to gaming to video calls. You can measure it with tools like ping and traceroute, and while you can't eliminate it completely, You can often reduce it by making smart choices about your network setup and the servers you connect to. Network latency might seem like a technical detail, but it shapes your entire experience of the internet. Every click, every page load, every message, they're all affected by those milliseconds of delay. Now, when someone complains about lag, you'll know exactly what they're talking about and maybe even have some ideas for what might be causing it.